Hey, what's up, folks? How's it going? This is Abhijit here, and welcome to DevOps Challenge Hub. So let's start with today's interview question, and let me share my screen. So today we are going to discuss about ECS, a few more questions in ECS. And before we go to interview questions, let's quickly revise ECS. So when user is going to type some URL or going to call some API, so that client user hits a load balancer ELB, and ELB we have listener and target group. So we have configured port number 80. So listener will be listening to that port. So request come to listener, and then it sends it to particular target group, and from target group it goes to EC2 instance, EC2 instances which are part of ECS cluster. And in EC2 instances, we have some ECS agent is running. So ECS cluster is managing all these EC2 where the containers will be running. So agents are there. So agents are talking to that uh, ECS controller, and then ECS agent will be allocating that task to ECS task, or allocating that job to the task. And then we have a task is nothing but your Docker container running Docker container. So this is the flow for if it is a launch type is EC2, right? So let's have a look at once again. Client user, it will go to ELB, then it will go to listener port, target group, then EC2 instance, then ECS agents running on EC2 instance, which will be delivering it to ECS task, and task is nothing but a running Docker container. And if you look at the security placement group, so you have the VPC virtual private cloud. Under that, you have subnets. Okay. And in the subnet, you have EC2 instance. And in the EC2 instance, you have ECS task, which is like a Docker container. And security group is attached to the EC2 instances. And in the security group, it says allow ELB listener port and outbound as per the app requirement. So what will come in and what will go out, you will decide. And you can have NACL also, and that you can apply at the subnet level. Network access control, you can assign at the subnet level, and there you can control inbound, outbound, both. And here you can specify what will be the inbound. ECS with forget launch type, almost similar flow. Client user, it will go to load balancer, then listener. From listener, it will go to target group. Target group, it will directly go to ECS task. There is no EC2 in between, and ECS task is running on Fargate. That is AWS computing resource, serverless computing resource. And ECS task is nothing but a Docker container running. And security and placement context, the virtual private cloud, it will have subnets. In the subnet itself, Fargate will be running, Fargate task will be running, which will be getting ENI, Elastic Network Interface. So it will be getting, because here we are going to use AWS VPC. So it will be AWS VPC network mode, and so it is going to get the private IP. And then we have the security group, which is attached to the this Fargate, which will be inbound, outbound. It will specify as per the requirement. So EC2 launch type, you manage the resource. Fargate, AWS manage the infrastructure. Scaling, EC2 manual auto scaling EC2. Fargate, it's a task-based scaling. EC2 launch type, shared or breach via EC2. And Fargate launch type, it's the ENI part task. We'll discuss in more details. And then ECS agent, it runs on EC2. Here, no need to run it because AWS manage Fargate launch type. And use cases, more control, advanced customization. And here it's a fully serverless, less operational overhead for Fargate. Okay, so now let's go to the question. What are the different network modes available in ECS? What are the different network modes available in ECS? So if we go to AWS documentation, we see that there are the couple of network modes available for EC2 launch type. For EC2 launch type, we have AWS VPC, then we have bridge, then we have host, and then none and default. And LAN as container on EC2, all these are yes, all these network modes are available. But if it is a Windows containers on EC2, AWS VPC available, bridge not available, host also not available, none and default is available. Okay. So host is uh, bridge is default for EC2. So containers share the host network but use NAT. So it will be container will be sharing the host network. Host is containers share the host network directly, no port mapping. And AWS VPC, each task gets its own ANI elastic network interface with private IP required for Fargate. So for Fargate, only AWS VPC is supported. So for Fargate, only AWS VPC is supported. And none means no networking used for advanced isolated scenarios. So bridge is like it task shares is to network. So it's like in a single room you have multiple rooms, right? And so you have to do some kind of mapping or labeling if you want to deliver, because a delivery will come through only one door, right? And in the three rooms, three paying guests are staying. So it has to be labeled properly because it has to address will be this particular house address, and then by name it will be going to the particular person. Maybe three paying guests staying in one room. So similarly, like three tasks are there. So that port mapping has to be there in bridge. And a host task uses same network as EC2. No port mapping is required. No port mapping is needed for host. So it's less secure but fast. So bridge, there is a port mapping 82, 8080. That port mapping is required for bridge. For host, task shares the same network, but it's less secure. And AWS VPC, it's same as Fargate. It's the best option for isolation and security. Everyone gets their own private IP. Right? So best one is AWS VPC network mode, where everyone gets his own ANI or private IP. And task-based networking, because they have to talk to internet, they have to communicate with other services like database or APIs. They have to receive traffic, and so we need to configure, and we need to understand that how ECS gives your task an IP address and allows traffic input in and out connects to the right network. So Fargate is serverless. We don't manage servers, and there we use AWS VPC network mode. So each task gets its own private IP. It's like a mini virtual machine. So it will have its own private IP. And bridge, you have to do port mapping. Host, it's a direct network. Like it's a fast but less secure, but no isolation. So bridge is like all containers live in the same house, sharing one door. You have to level each room. That is the port mapping to deliver things. AWS VPC mode, each task lives in its own house with its own address and security gate. So this is private IP plus security group, AWS VPC mode. And Fargate, it's must, like this is the only option. And for EC2, there are multiple options. This is one of the options, and this is the best one. Okay. So next question is, how do you integrate ECS with application load balancer? How do you integrate ECS with application load balancer? So why we need load balancer? Because we want to balance traffic across multiple ECS tasks or containers using load balancer. And this will give high availability, automatic health checks, and support for updates with zero downtime. So this can be done using blue-green deployment. There can be two different target groups we can set, and if one target group, like that is the old one, we can replace with the new task. So one new task. Once we are happy with that, that old target will drive the traffic. Let's switch the traffic from old target group to the new one. So that is the blue green one. High availability because load is getting balanced across multiple container or traffic, and there will be automatic health check that we'll discuss in the next question. So we have seen this flow. Client request goes to ALB, application load balancer. Then it goes to listener. Load balancer will have listener and target group. Listener port 80. And there will be some routing rules, path-based rules like API or web. If it is yourcompany.com/API, yourcompany.com/web. So API means it will go to this particular target group. /web means it will go to different target group. And there are certain tasks ready to do that service. So if we give some analogy, like you go to some restaurant and then you ask reception, where is the tea counter, where is the dosa idli counter, and based on that they will guide you that go to the counter 1 for tea and go to counter 2 for dosa idli, like that, right? So here the request comes. If it is an API request, it go to the target group, API related target group. And if it is a web related request, fetching the web page, go to the other target group, right? So target group, and then it goes to ECS task, running container with IP and container, your app. And once ECS, okay, so let's see how we are creating this. So first we create the ALB, application load balancer. We can create from the command line application load balancer. So we mentioned the load balancer, security group, etc. And once we create the load balancer, and there should be like two subnets for in different availability zones. Then we create a target group. We create a target group, and a target group will be like if it is a target task will have private IP. So target is IP. So when a new task comes, they register with that target group. New task appears, and it is going to register with the target group. That I'm going to serve it. I'm going to serve it, right? So that way. So for example, another counter comes, T counter. So they're going to register with the reception that you can send to counter 1. You can also send to counter 3. You can also send to counter 4. There also we are serving T because the load has increased. A lot of people started coming, and we need to serve more T. So we have opened 4-5 counters. So people come to reception, they will be converting to 4 different counters. And if load is reduced, then only one counter will be running. And they will be deregistered. They will say, no, we are not serving anymore. So they will deregister. So that is the same way. Define listener and listener rules. You create a listener. So you have created a listener, you have created target group. Already you have created this application load balancer. And then configure ECS service to use LB. Now you have created your load balancer with listener and target group. Listener is the incoming, it will hit, then it will send to target group. Target group, you have to map with this ECS service. So ECS service, you will be mapping. Okay. So analogy is like your restaurant with multiple chefs or container, and ALB is the receptionist who takes incoming customer and routes them to any available task depending on your order or URL path. Right? That web or API, based on that, it will divert. Like tea or idli dosa, based on that, it could be sending to proper counter. Okay. So steps, what you do, create ALB with 2 subnets to distribute traffic. Then I create a target group to receive traffic from ALB. Right? A listener and routing rules to tell ALB where to send traffic. And attach ALB and target group to ECS service to link container with ALB. So they are the 4 steps we follow. So we create ALB with 2 subnets. Then we create listener and a target. Listener and target. Request comes to listener. Then based on the routing rules, it sends to target group. Target group goes to the task. Task is registered with the target group that I can also handle. Right. So what are the target group? Health checking in ECS. So health checking, let's say your task for some reason hung or not able to respond, or some memory corruption, or it's something happened and it's not able to respond. So once in a while, it will make a call to your health endpoint and see whether it's responding or not. It will ping maybe 30 seconds. Every 30 seconds, target group sends a health check request like a ping to or HTTP call to each task regularly every 30 seconds and see whether it's healthy or not. If it responds okay, then they mark healthy. If it fails several times, it marked unhealthy and removed from the load balance. Sometimes what happens like a load has increased and T counters opened, okay, and so it's saying that go to counter one, counter two, counter three, and they have registered. And for some reason, counter three is busy, like maybe he forgot to inform, or he fell sick or something, or he got some urgent call. He could not inform the counter. Right? So this guy will keep sending. So that won't be right. So he'll be like he himself, because he forgot to inform the counter that I won't be serving tea anymore. So counter three won't be serving tea anymore. So this guy will be calling health check, ping. Are you there? Are you there? Are you serving? Are you serving? And if this guy is not responding because he is busy with some other emergency call, so he will know that okay, counter three for some reason he is not able to serve. So I should not send people to counter three. I will be sending to counter one and counter two. So that's the health check. Now suppose you have two types of ECS tasks. One set for video conversion, another for image conversion. And now we use LB with listener rules to route request based on the path, like image conversion and video conversion. Image conversion, it will be converting image maybe JPEG to PNG, and video conversion, maybe it will convert MP4 to MOV, different format. And if there are 100 tasks running on for image conversion, how does ALB target group forward requests to all these tasks? And how are the incoming requests distributed or mapped to the 100 tasks? So there are like a lot of requests are coming, a lot of API calls are coming, and everybody wants like want to convert their image, right? I want to convert my image PNG to JPEG because it's just compact. It's a compressed one. It's a smaller image. So everybody is requesting that. Some similarly like video conversion also there are like 100 requests are coming. So how what will be the flow? So flow will be like LP distribute request to ECS task. So ECS task register with the target group. Uh, ECS task will be registered with the target group. And so here uh, there will be dynamic checking. Okay, there will be dynamic checking. So this LB will distribute the request to ECS task. So if it is a AWS VPC, each task will have its own private IP and it will register. So your application load balancer will maintain a list of healthy tasks, basically IP and port number, and it will be maintaining that. And then it will be using load balance algorithm. It can be a round robin algorithm by default. So request one go to task one, request two goes to task two, request three go to task three. So it will be that way it will be serving round robin mechanism. So a client request to image conversion process, then it will be listener rules matches image conversion, and there are like 10 tasks registered. So one by one it will be sending. And if it is a target, if there are like 10 tasks are busy and more request comes, then AWS will escalate it. If it is a EC2, and then task, there will be two level of scalings. Like one is the task level. Let's say like there are two tasks running on EC, one EC2 instance, another two more tasks running on another EC2 instance. Now EC2 instance, let's say it can run three tasks. So one more request comes. So in the first EC2 instance, it will create one more task. Another request comes, it will create another task in second EC2 instance. Now three running. Now one more request comes. So it cannot run the task in EC2. So EC2 has to start. So EC2 has to scale up now, right? Earlier task was scaling up, more task, more request. Now we need to run another EC2 instance. Their new task will be created. So that has to be scaled up using auto scaling group. You can set up auto scaling group that if a CPU is more than 80%, we need to create one more EC2 instance. Or memory usage is more than 70%, we'll create one more EC2 instance. So automatically it will scale up. And dynamic health check will be there. Unhealthy tasks will be automatically removed. So this is the way load balancer using round robin mechanism will distribute the task, and there will be a target group. Target group will be created. Image conversion will be one target group. Video conversion will be another target group. And the related task will be registered with their respective target group. How do you implement blue-green deployment with ECS and ALB? Blue-green deployment. As we discussed that blue-green deployment means running two versions of your app. One is the old one, blue, and new one is the green. And why blue-green deployment is required? Because you don't want downtime. Already some old things are running, and you want to make sure that, like let's say, like you are already have one counter, you are serving food, you make another counter ready, and you want to for some reason like close this counter because this space has to be freed up or something. So another counter is set up. Once that is ready completely, then only you divert the traffic. Similarly, one like environment one cluster, one target group already serving, another target group you created. Once that is ready to serve, you say that don't go to this target group, don't go to the blue one, go to the green one. Don't go to /blue, go to /green, right? So ECS runs two tasks behind same LB, behind the same application load balancer. So users doesn't know the thing. User is going to the same load balancer. User is hitting same load balancer. Backend user, based on the rule, it is going to the blue. But once green is the target group, all the tasks registered, it will be traffic will be going to the green. So user doesn't know. User goes to the ELB and backend that target group, blue to green task is going. So that's a blue-green deployment. ECS runs two tasks, blue for old, green for new version. Behind the same application load balancer, target groups are created for each version, both connected to LB. So for old also created one target group, and new also created another target group. And you use listen and rule or code deploy to shift traffic from blue to green after testing with zero downtime. Right? So why this is important? Because you can test safely, roll back easily, and deploy without downtime. You can deploy without downtime, keeping users happy even during the updates. So what are the security group consideration for ECS task? So forget we are using AWS BPC mode. So each like each task will have its own IP. It's like a virtual machine. So security group will be directly assigned to the task. We can assign security group directly to each task. Right? Allow only necessary port and place task in private subnet with NAT if they need secure internet access. Right? And for EC2, it can be a bridge and host mode, but we can also use the AWS VPC mode also. So bridge host mode means security group will be attached to EC2, not the task. Security group will be attached to EC2 instance if it is a bridge and host mode. It won't be attached to the task. Security group will be attached to the EC2 instance. So best practices: list privilege, only open a required IP and port, avoid open to the world unless truly needed, and use security group, NSM, network access control list, and private subnet for layered security. So this is a standard practice. List privilege, don't open to everyone. Whatever required, open that one, and use security group, network access layer, and private subnet. So these are the three things for layered security. Right. Now let's go to today's quiz section. Which network mode is required for target task in ECS? So we know that AWS BPC is the one. In ECS, what does the AWS BPC network mode do? AWS BPC network mode do. View or connector IP assign each task its own ANI and private IP. Answer is C. So you can pause and try to answer yourself. You can pause the video and try to answer. What is the default load balancing algorithm used by LB? So it's round robin. In ECS with LB, what is the role of the target group? In ECS with LB, what is the role of the target group? This will development list of this task. I feel that port operating strong. It maintains the list of ECS tasks and IPs and port for routing. The target group listener, then target group. Target group goes to the list of tasks which are registered that I can do the job. What is the primary benefit of using AWS VPC mode on both EC2 and Fargate? Isolation and security, because it has its own IP and security group. So it has a better security and isolation. Answer is C. In blue-green deployment with ECS and ALB, what is the main advantage? It is already like allowed zero downtime switching between the app version. So this is the answer. Answer is B. So that's it for today. Hope you like this video. Please like, share, and comment, and subscribe to my YouTube channel, and also follow my daily page DevOps channel. I post quiz and contest daily. You can participate in that, and you can also follow my WhatsApp channel. I provide regular updates there. So thank you for watching this video. See you again in the next video.